In this video, we're going to look at two very important theorems in the study of algebra. In particular, topics involving polynomials, finding the zeros of polynomials, solving polynomial equations, and so forth. So these are the remainder theorem and the factor theorem. So let's look at the statement for the remainder theorem. It states, let f be a polynomial function if f of x is divided by x minus c, then the remainder is f of c. So just to make clear what that means, let me look at, say, the polynomial. I'll call it f of x. I could call it p of x. It doesn't really matter. But f of x is equal to, say, x squared minus 9. Okay, this in turn factors into x minus 3 and x plus 3. So it should be clear to you that this polynomial x squared minus 9 is divisible by x minus 3 and x plus 3. Okay? Or another way to say it is it has a factor of x minus 3 and a factor of x plus 3. So if I divide this polynomial x squared minus 9 by x minus 3, I should get a remainder of 0. Or if I divide it by x plus 3, I should get a remainder of 0. Okay? Because divide it evenly, just like with numbers. If I take say 6 and I divide it by 2, I would say the quotient is 3. The remainder is 0. Whereas I have something like, say, 7 divided by 2, I would say this is equal to 3, remainder 1, or I could write it as 3 and 1/2. Okay? So getting back to this theorem then, this is saying then if you divide the polynomial by x minus 3, then the polynomial evaluated at c, which in this case would be 3, should give you the remainder. Okay? So it should be clear that if I replace the x by 3 either in this form of the polynomial or the factored form, 3 squared is 9, minus 9 would be 0. Okay? So the 3 in this case would be the c in this particular theorem. Okay? Okay? In the same way, if I divide the polynomial by x plus 3, I also get a remainder of 0. So that would tell me then that in this case the c would be negative 3. Okay? Because it has to be in this form, x minus c. So x plus 3 can be written as x minus a negative 3. So again, if I replace the x by negative 3 either in this format or over here in the factored form, I'm also going to get 0. Okay. So that's basically what this particular theorem is telling you. At the same time, it should be clear to you that if you evaluate the polynomial at a certain number, in this case 3, then x minus that number will be a factor, right? So x minus 3 is a factor. F of negative 3 is 0, so x minus a negative 3 should be a factor. Okay? So the factor theorem is directly related to the remainder theorem. Okay? It's derived from the remainder theorem. So if you look at the factor theorem over here, let f be a polynomial function, then x minus c is a factor of f of x if and only if f of c is equal to 0. Okay, so that's what we have up here. If you evaluate the polynomial at a certain number, whatever value you get is the remainder. Okay, that's what the remainder theorem is telling you. But if that number turns out to be 0, then that's telling you that that factor divides, that x minus c divides into the polynomial. So from the factor theorem then, you evaluate the polynomial at a certain number and you get 0, then x minus that number is a factor. Okay, f of 3 is equal to 0 over here in this first example, so x minus 3 is a factor. F of negative 3 is 0, so x minus a negative 3, which is x plus 3, is a factor. Okay, and that's what the theorem is telling you. Now this works both ways. If x minus c is a factor, then you know f of c is equal to 0. Okay, that's just what this if and only if. It goes both ways. So let's clear this and just look at some examples here. Divide x to the third minus 2x squared plus 5x plus 2 by x minus 1. Okay. Now I'm going to do the division using synthetic division, short form. And you can do that anytime you're dividing by a binomial of degree 1, which is what this is, x minus 1. The exponent of the x is 1. So the way it works is we write the coefficients of the polynomial or the dividend on a row here. And the polynomial has to be in descending powers. Okay, x to the third, x squared, the x, and then the constant. So it has to be in descending powers. If there are any missing terms, you place a 0. So in other words, if I don't have an x term, then I put a 0 where the 5 is, and so on. Okay, so in this case, I'm dividing by x minus 1. So you put a 1 here. If you're dividing by x plus 1, you put a negative 1 there, because it has to be in the form x minus c. So I bring this down like this, and then I go 1 times 1 is 1. I bring it over. Okay, and then I add here. I get a negative 1. 1 times negative 1 is negative 1. Bring it down, or add these, we get 4. 1 times 4 is 4. Bring it over to the next column. Add the 2 and the 4, we get 6. So this tells me then that the coefficients of the quotient come from this last row here. Okay, so this was an x to the third, so that reduces by 1 power because you're dividing by a power of 1 degree, a first degree I should say, first degree binomial. So it reduces from x to the third to x squared. So the coefficients then of the quotient should be then 1 x squared minus 1x plus 4, and then the last entry in that bottom row is the remainder. So the remainder is equal to 6. Okay, so here I divided the polynomial by x minus 1, and I got a quotient of x squared minus x plus 4, remainder of 6. Now let's suppose they give you the same problem and they just want the remainder. Okay, suppose they say, what is the remainder if this polynomial x cubed minus 2x squared plus 5x plus 2 is divided by x minus 1? Well, you can still do it this way, and you can say the remainder is 6. Or you can just evaluate the polynomial at 1. Okay, so in other words, I'm taking, this is my polynomial f of x, and I'm replacing the x by 1. So 1 where the x is, so 1 cubed is 1. 1 squared is 1 times a minus 2 is still a minus 2. 1 times 5 is 5. And then it's a plus 2. add this up, and whatever number you get is the remainder that you would get if you actually divided it out. Okay, so you combine this out, you get 6. Okay, so if you're just looking for the remainder, that's all you got to do. Now, also keep in mind that because of the factor theorem in combination with the remainder theorem, if they ask you, is x minus 1 a factor of this polynomial, then the answer would be no, because for it to be a factor, the remainder has to be 0. We didn't get 0. We got 6. Okay? Clear this? Okay. And the next one, they're asking, is x minus 3 a factor of x cubed plus 4x squared minus 11x minus 30? Now, you could do the division and figure it out. Okay, so let's do it that way first. So we're dividing. We want to know if x minus 3 is a factor, so we want to divide by x minus 3. So in this case, the c would be 3, so I put a 3 right there. And then the procedure is I bring down the first value of 1. Remember, these have to be in descending powers, these coefficients of the polynomial. Or I should say the terms have to be in descending powers, and then you take the coefficients in each of those terms. So it's 1, and 3 times 1 is 3. Add the 4 and the 3, we get 7. 3 times 7 is 21. Bring it over to the next column. Add those up, we get minus, or 10, I should say. And then 3 times 10 is 30. And minus 30 and 30 is 0. So I did get, remember the last entry is the remainder, so if you divide that polynomial by x minus 3, the remainder is 0. So the answer is yes. It is a factor. And I want to point out to you that one of the uses of this, applications of this, is if you're trying to solve an equation or you're just trying to find the zeros of a polynomial, this is how you would start. Because now you know that this polynomial right here factors into, because we got 0. And again, point out that another way to solve the problem is evaluate the polynomial 3. So put a 3 where the x is, and that's also going to come out to 0. Okay, so using the factor theorem, I would just replace the x by 3 instead of doing this right here. Since I just want to know if it's a factor, I could just replace the x by 3 and I get 0. So again, the answer would be yes. But just to take it a step further here, because of this, you know that the polynomial factors into, or has a factor of x minus 3. Okay, because of what we got here. And then this 1, 7, 10 are the coefficients of the quotient. So because we started off with the third degree, this reduces to second degree, so this should be x squared plus 7x plus 10. Okay. So it's x minus 3 times this. But since this is a quadratic, you can factor that out in this case. This will factor into x plus 5 and x plus 2. Okay. So using these ideas involving the remainder theorem and the factor theorem, if they ask you to factor this polynomial, this is what you would do. Okay. Now if they ask you to find the zeros of the polynomial, okay, very easy. It would be 3, -5, negative 2. Okay? So these are just, I'm just giving you different types of problems that you could get from this type of situation. So if they ask you for the zeros, you would go through this procedure here to determine that x minus 3 is a factor. And then if you do the synthetic division, you're able to break it down into x squared plus 7x plus 10, which factors into x plus 5, x plus 2. And from that, you can get the complete zeros, 3, negative 5, negative 2. In the same way, if this was an equation, so let's suppose you had x to the third plus 4x squared minus 11x minus 30. Let's say that was equal to 0, and you were solving the equation. Well, you'd go through the same process, and you would say the solution to that equation is x equal 3, negative 5, or negative 2. Okay. So these are the applications of the remainder theorem and the factor theorem. They're both related, and they're again very helpful in problems involving polynomials. So this concludes the video. Again, you have any questions or recommendations for videos that you want to see on certain topics, please feel free to post. And if you're subscribing to the channel, I would have no problem listening to your requests. Thanks for watching.